Hi, I'm Kimberly, and today I'll be talking about my ENG Math3 assignment presentation. We're given the question dy dx is equals to x squared plus 1 over y. Given initial value of y is equals to 1 when x is equals to 0, we are told to find the approximate value of y when x is equals to 1. So by drawing the curve over here, we know that x naught, aka x is equals to 0, y naught will be equal to 1. So we draw a tangent line over here to find out when x naught is incremented by h at x1, what would the approximate value of y1 be? We repeat this process again until we find x is equals to 1 over here, this point. We could see that by joining the lines of the approximate values of y, it follows closely with the curve. So, we know gradient formula for this case is y1 minus y0, y0, over h, the increment value, which would then be equal to dy over dx, x naught, y naught, which can also be expressed as y prime x naught. By manipulating the equation over here, we could see that y1 is equal to y naught plus h times y prime x naught. So we could continue this to get the general equation over here that yn would be equal to yn minus 1, the previous value of y, plus h, increment value, step size, y prime of x, n minus 1, the previous value of x. This brings me to Euler's method. Taking my step size as 0.1, we could put x as all the increment value plus the previous value of x. So 0.1, 0.2, 0.3, all the way till 1. Y would then, in this case, be that formula that we showed earlier. And y prime over x, we substitute in using this formula, dy dx, x squared c7 plus, x squared plus 1 over y. So by doing this, we can find the approximate value of y when step size is 0.1 would be this, 1.911375. Using the analytical method, we could find dy dx is equals to that. We cross multiply it, integrate it to find y squared over 2 is equals to x cubed over 3 plus x plus c. Substitute in the given initial values to find c, which would be equal to half. We manipulate the equation to find out that y would be equal to square root 2 times of x cubed over 3 plus x plus 1, which would give me 1.914854. To find approximation error, we take the y value found through the analytical method minus the Euler's method. This would give me 0.003,0003479. Now we try it with a smaller step size. We notice that the approximation error is actually much lesser, 0.00192, and the y value is actually closer to the value found in the analytical method. This is because when the increment value is smaller, the points follow more closely to the curve, henceforth giving a more accurate answer. That is all for today's presentation. Thank you.